4.8 is on second derivative interpretations. We're going to do a little bit more of what we did in the last objective. If f prime 2 is 0 and f double prime of 2 is negative 3, what can be said about function f at 2? So if my first derivative is 0, I have a critical number. Right here, 2 must be a critical number, possibly a maximum, maybe a minimum, or maybe it just happens to be something else, like a point of inflection. So let's see what else we're given. We're also told the second derivative at 2 is negative. So we're specifically just looking at whether it's 0, positive, or negative. So a negative second derivative tells me that at 2, my function is concave down. So if it's one of these possible things where your function is also concave down, then it must be that at 2, I do have a relative maximum. So we'll go ahead and say at x equals 2, f has a relative maximum. In number 2, if f prime negative 1 is 0, and f double prime of negative 1 is also 0, what can be said about f at negative 1? So I have something similar to the last problem. The first derivative is 0. This tells me it could be a relative max or min, but it doesn't have to be. All I know is that it is a critical number, so possibly a point of inflection. So let's see. I would only know if it's a point of inflection if it's mentioned that the concavity changes at negative 1, and that wasn't said here anywhere, so I don't know that. Then I'm told my second derivative is 0, not positive, not negative, but equal to 0. So it's possible that the function has no concavity at this point, or it's possible that there's a change in concavity. Now, we don't know that these things aren't true or that they are true. So all we can really say here is that we know we have a critical number at x equals negative 1, or the slope of my tangent line is 0. That's the best we can say. We can guess at other things going on, but we don't really know. Okay, so let's take some information here in problem number 3 and sketch a graph based on that information. So we want a graph of f that follows the characteristics given here. So first up is some information about the original function, some points that we can plot. Okay, and now some information about the derivative of the function. And a little information about our second derivative. Alright, so I'm going to use this information to draw a possible sketch. And by possible, I mean there can be some differences between your graph and my graph or each other's graphs. But some of the characteristics, they'll have to be the same. For instance, f of 0 has to be 4. So we'll have the point 0, 4. F of 6 has to be 0, and f of 2 has to be 0. So these are points that your graph has to have. Then I know my derivative doesn't exist at 2, my derivative at 4 is 0, and then I have positive and negative values everywhere else. So I'm going to take that information about my first derivative and make a number line out of it. So my first derivative, number line test. I have at 2, my derivative does not exist. At 4, the derivative is 0, so I should have a horizontal tangent line here. And then we have positive when x is between 2 and 4, negative when x is less than 2 or greater than 4. So what does this tell us about function f? It tells us that f is decreasing, then increasing, and then decreasing. Okay, so we want to decrease connecting these 2 points. So we would decrease through here. Now, it doesn't say I have to stop here, but I should start increasing here, and it's not differentiable. So the point exists, so it's continuous at 2, but if it's not differentiable, it must be that it's not smooth. So I need to have a sharp turn at 2. At 4, it is a derivative of 0, so my curve should be smooth and continuous. But they're not really telling me for what, for something. So I'm going to need to pick some point, and then it's going to decrease back the rest of the way. So if I have to increase 2 up to 4 something, who knows, it's up here, and then decrease back through 6 to finish. Then we have our second derivative information. We're going to take this guy here and do our second derivative. And we have, as long as x does not equal 2, my second derivative is negative. So what does that mean about f? F is concave down everywhere, except at 2. What's happening at 2? Is my second derivative 0? No. If my first derivative at 2 does not exist, then my second derivative at 2 does not exist. Okay, so watch out for that. So what we want to do is just follow the 2 things, decrease, increase, decrease. And again, we can start with a pencil here and mark this in. Decrease, increase, until we get to the x value 4 for something. So we'll just kind of make it look natural. And then decrease again from 4. Got to go through 6, 0 there, all the way down. There's decrease, increase, decrease. Then I fill in my concavity. It's supposed to be concave down the entire time. So this line here needs to be facing downward, concave down as it decreases, concave down as it increases, concave down as it decreases. And remember, it's supposed to be a nice, smooth, continuous turn at 4 because the function was differentiable there. But it should be a sharp turn of some kind at 2 since it's not differentiable there. So that makes sense why we had that concave down there. I'll go back over that. Decrease, concave down. Increase, concave down. Decrease, concave down. And there is a possible sketch of f.